In this section, we will cover solving absolute value inequalities. Let's go back for a second and review what is an absolute value. Now, an absolute value is designated by the two bar symbols, measures the distance a number is from 0. So let's say that you are given the statement, the absolute value of x is equal to 5. What this means is that x is 5 units away from 0. So that means that x could be at either positive 5 or it could be at negative 5, because both the positive 5 and the negative 5 are 5 units away from 0, regardless in what direction they are located from 0. So then absolute value inequalities represent the following. If the absolute value of x is greater than a, that means that we want all those numbers that are a distance greater than a from 0. If you are given that the absolute value of x is greater than or equal to a, not only do you want the distance to be greater, but you can also include that value of a. For the absolute value of x is less than a, you want a distance that is less than a, but you're not including a. And for the absolute value of x being less than or equal to a, you still want a distance that is less than a, but now you are allowed to include a. We have to be very careful with these two last statements, because the absolute value of any number is either 0 or positive. It can never be less than or equal to a negative number. So let's do example 9. Example 9, they're asking us to solve and give the solution in interval notation. So let's take A. This one is the absolute value of x is greater than 3. So what we're going to do is we're going to go back to the equation. We're going to take that the absolute value of x is equal to 3. This means that x is either located at 3 or x can be located at negative 3. So if I go to my number line, here is 3, and here is negative 3. Now I go back to the inequality, and I see here that I want that distance to be greater than 3. Because we want it to be greater, we are going to be moving away from 0 and not towards 0. So I'm going to shade on the right side towards infinity and on the left side towards negative infinity. I go back to the inequality and we are not including that 3. So then we're going to place parentheses. And now that I have my solution graphed in a number line, I am ready to write the interval notation. We read the graph from left to right. So this is negative infinity to negative 3, and then again from 3 to infinity. Because we are not including the 3, these will take parentheses, and remember, infinity always takes parentheses. And because our solution is broken into two pieces, we're going to place a union. Let's try it again with B. B reads, the absolute value of x is less than or equal to 3. So I'm going to go back and create the equation. The absolute value of x is equal to 3. In this case, it states again that x is 3 units away from 0. That means that x is either at 3 or at negative 3. I find those values in my number line. Here is 3 and negative 3. I go back to the inequality. In this states right here that I want the distance to be less than or equal to 3. That means if I want less, I'm not going to shade on the outside because the outside will be farther away from 0. I want the distance to be less. So that means that I'm going to have to shade inside, inwards from 3. So then from 3, I'm going to move towards 0. And from negative 3, I'm going to move towards 0. And I check that I do include 3, so then the negative 3 will take a bracket, and so will the positive 3. Once I find my shaded region in the number line, I read the number line from left to right, and I notice that this is being shaded from -3 to +3, and we are including those values. So what do we notice then? Well, we're going to notice that when it's greater than, we are shading outside towards infinity and -infinity, and when it's less than, we are shading inside.
Thank you so much for watching, and I'll see you in the next one.